Hi, I'm going to go over the degrees and radians on the unit circle. So degrees and radians are very similar. It's kind of like a Fahrenheit Celsius. They both measure angles, but just in a different way. And when we get to higher math classes, we actually want to use radians for lots of different reasons instead of degrees, which is more for simple geometry and triangles and things like that. Okay. So the basis of a radian, like what is a radian? So it's all based on the idea that the circumference of a circle, if you recall from elementary school, is 2 pi times the radius, right? Now, we want to use something called the unit circle, which means the radius is always equal to 1. So in this formula, if we have a radius that's equal to 1, it's simply just 2 pi times 1, or just 2 pi. Now, circumference is the distance around, or the perimeter. We don't say perimeter with circles, we call it circumference. So if we just walked, starting here at angle 0 and walked all the way around, the distance is 2 pi. Now you'll notice we leave it as 2 pi instead of doing 2 times 3.14, which is 6.28. We could think of this as 6.28 feet if we walked all the way around, but we usually leave it in this format. It's very similar that, why we leave answers like as square root of 2, and we don't estimate it. We don't get a decimal for it. We just say, okay, the answer is root 2. Okay? So, but it does have a decimal representation if we need to have one. Okay? So to go all the way around, let's say this is 0. If I go all the way around, right back where I started, that's 2 pi. And that's the same as 360 degrees. So 0 and 2 pi are the same as 0 and 360 degrees. Which means if I go halfway of 360, that's 180. And then half of 2 pi is just pi. So if all the way around is 2 pi, halfway around is pi. And I can use this system of just figuring out what all these other angles are throughout the unit circle. All right, so for instance, if I want to find out, well, what's 90 degrees up here? Well, half of 180 equals 90. So that's the degrees. So what I want to do is take half of the radian. So if I know pi is equal to 180, I'll take half of pi. And that's the radian measure for 90 degrees. So 90 degrees is the same as pi over 2, or half of pi. Right? You can think about it like this if you want. We usually write it this way, though. But they mean the same thing. Right? And hopefully that makes sense. We're taking half of 180 and getting 90. So we're taking half of pi in radian units and getting half of pi, or pi over 2. And we can continue this, going the other direction as well. So we have 0, and we got a half of pi, and we have another half, right? Gives us 2 over 2 pi. And we can keep on going to get down here, which is 270 degrees. And this is 1.5 times around. 1.5 as a fraction is 3 over 2 pi, or 3 pi over 2. Okay? So we have 1 over 2, 2 over 2, which is 1, and then 3 over 2. And we can keep on going and say, well, this must be 4 over 2, but 4 over 2 equals 2. So there's a nice system here to find these values if we need to figure it out. Now we also have other angles here. Now this is the halfway point between 90 and 0, which would be 45 degrees, right? So what's 45 in radians? Well, if I take half of 90, I get 45. So if I take half of pi over 2, half of that, right, it's going to be 1/2 times pi over 2, that's pi over 4. Okay? So all I did is just multiply this by 1/2. I got pi over 4. So that means every 45 degree angle is really like 1/4, right? You can think of it as 1 pi over 4 if you want. Okay? So 1/4 pi. So if I add another 1/4 from 45, I'll get 2/4, right? So I'll have 2 pi over 4. You'll notice how that reduces to pi over 2, because that's 90 degrees as well. So there's multiple ways of getting this, and I can continue this all the way around. If this is 1 pi over 4, this is 2 pi over 4, or Well, the next multiple of 45 degrees would be over here, and that's going to be 3 pi. So I'm just adding another fourth each time. The pi over 4 isn't changing. It's just how many of those, that's what this number is. Right? And I can keep on going. Add another 45 degrees. That's going to be right here. That would be a 4 pi over 4, which, as you can see, 4 over 4 cancels and equals just pi. And I can keep on going down here. That would make this 5 pi over 4. Okay? And I can go down here. Next 45 degree angle, this would be 6 pi over 4. And 6 over 4 reduces to 3 over 2. So you can see how they all have like a check and balance on each other. If you get the answer using one method, you also get the answer using another method that confirms the first method. And we can keep on going. The next multiple here would be, so we've got, what, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. So you can see the pattern. And that's really the key about learning the unit circle, is seeing the pattern, not memorizing that, well, this angle is 7 pi over 4, but, well, the one before it is 6 pi over 4, and the one after it's going to be 8 pi over 4, which, of course, 8 over 4 equals 2, right? 2 pi. So that's for all the increments of 45 degrees, right? Technically, this is 45 and 135, and this would be 225, right? But we don't need to know the degrees so much. We need to know these new radian values. And you can also notice that on each one of these 45 degree increments, they're all over 4. Right? So patterns are all over the place. It's good to observe those as you're going along, because it'll help you recreate these things a little bit easier. Okay, so there's 2 more increments here. We did the 45s. The next one we're going to look at is these right here, which are 60 degree angles, and those increments of 60 degrees. So like we did the last one, we asked, like, well, how do you get from 180 to 90? Oh, you divide it by 2, so we get pi over 2, right? Well, how do you get from like half of pi over 2 will give you pi over 4. So we can look at this and say, well, how do I get from 180 degrees to 60 degrees? Well, if I divide that by 3, 180 divided by 3 is 60. So if 180 is pi, and I divide pi by 3, I get pi over 3. So that's the radian for 60 degrees, is pi over 3. Notice how it's over 3 and not over 4 anymore. And I can do the same method and just count increments of 60 this time instead of 45. So 60 would be 1 pi over 3. The next increment of 60 will be right here, which will be 2 of the pi over 3's, right? That's 120 degrees over 3. The next increment of 60 is actually 180. And you'll see once again, well, I got 1 pi over 3, 2 pi over 3. This would be 3 pi over 3, right? Which, of course, cancels out to just pi. Next increment would be down here, which will be 4 pi over 3. Keep on going. We have 5 pi over 3. Keep on going, and it brings us back over here, which is 6 pi over 3. But, of course, 6 over 3 is 2. So we got 2 pi again. And lastly, we'll have the 30 degree increments right here. Right? And we'll use the same method. How do I get from 180 to 30? Well, I'd have to divide by 6. 18 divided by 6 gives me 3. So 180 divided by 6 gives me 30. So I'm going to take pi and divide it by 6. So 30 is the same as pi over 6. Now, we can count 30 degree increments, but we already have answers for all of those. But we can still use the same method. For instance, pi, this is 1 over 6. The next increment of 30 is 60, so this would be 2 pi. Oh, sorry. Yeah, 2 pi over 6. And 2 pi over 6 just reduces to 1 over 3. And this would be 3 pi over 6, which of course reduces to 1/2. Keep on going and do that, but we don't need to write them all out because we already have the reduced value, right? So it's okay if we don't have these other here. We can just write them out and say this is 1 pi over 6, 2 pi, 3 pi, 4 pi, 5 pi, right? That's the one that's missing. So this is 5 pi over 6. Then we have 6 pi over 6, 6 over 6, right? 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. And if you keep on going, you get 12 pi over 6, which of course 12 over 6 is 2 pi again. Right? So we filled out the entire unit circle now. Right? Just taking fractions of 2 pi, which is based upon the circumference of the circle formula. Right? So what you want to be able to do is recreate this as needed. And at some point, after doing this system long enough, it's going to be like the new multiplication table of higher math. Right? You don't use degrees anymore. You'll just get used to seeing pi over 4 and pi over 3. You know, the name of the game is, you know, find the piece of pi, right? Because all these are just fractions or pieces of, you know, the number pi. So after a while, it'll take you 2 seconds or less to, you know, really remember all of these. But you don't have to do it right away, but just know that's the eventual goal, is to have this memorized. So all your future calculations go a lot easier. All right? Okay, so let me know if you have any questions. I'm always here to help.